Hi everyone, welcome to Lecture 6 on Basic Inorganic Chemistry. My name is Dr. Teresa Chimambam. For today's lecture, we will cover types of chemical bonds. So we will look at covalent and electrovalent bonding. So we start with covalent bonding. What is covalent bonding? Covalent bonding is the sharing of electron pairs between atoms in a molecule. So the sharing of electron pairs between atoms in a molecule is known as covalent bonding. Let's have a look at one example of covalent bond. A covalent bond is formed between two chlorine atoms to form Cl2 molecule. Each chlorine atom has 7 electrons in its outermost shell. This chlorine also has 7 electrons in its outermost shell, but each chlorine atom needs 8 electrons to be stable. So, what a chlorine molecule does is then to share these 2 electrons. So when the 2 chlorine atoms share these 2 electrons, each will then have 8 electrons in its outermost shell, which each needs to be stable. So if you count the number of electrons for this chlorine atom, it will be 1, 2, 3, 4, 5, 6, 7, 8. And for this chlorine atom, 1, 2, 3, 4, 5, 6, 7, 8. So each chlorine atom now has here 8 electrons. And when this happens, a covalent bond is then formed between two chlorine atoms to form chlorine molecule. So another example of covalent bond is found in hydrogen molecule. So each hydrogen atom has 1 electron in its outermost shell, as you can see here. But each hydrogen atom needs 2 electrons to be stable. So what it does, just like the chlorine molecule, it will share the 2 electrons. And when it shares, then each atom will then have 2 electrons. This one has 2 electrons, and this one also has 2 electrons. So what happens then is that a covalent bond is formed between 2 H atoms to form H2 molecule. So now we look at ionic or electrovalent bonding. So we either call it ionic or electrovalent bonding. What is electrovalent bonding? Electrovalent bonding or ionic bonding involves the transfer of valence electrons between atoms. Electrovalent bonding involves the transfer of outermost electrons between atoms. Let's look at an example of ionic bonding. An ionic bond is formed between sodium and chlorine. Sodium has atomic number 11. It has 3 atomic orbitals and its electronic configuration is 281. Sodium has 1 electron in its outermost shell. Chlorine has atomic number 17. It has 3 atomic orbitals and its electronic configuration is 287. Sodium needs 7 electrons in its outermost shell for it to be stable. But it is easier for sodium to lose this 1 electron than gain 7 electrons in order to become stable. This is because if sodium loses 1 electron, it would then have the maximum that it can have in the first shell, which is 2, and it will also have the maximum that it can have in the second shell, which is 8. And in this way, sodium will be more stable. So it is easier for sodium to lose this 1 electron and become more stable than gain 7 electrons. And atoms will always choose the easier path. So sodium will choose the easier part, which is to lose this one electron in order to become more stable. For chlorine, chlorine will choose to gain one more electron and become more stable because it needs 8 electrons in this third shell than to lose these 7 electrons. So what happens then is that sodium will lose this one electron. So when it loses this electron, it will become positively charged, and that electron will then be gained by chlorine. So when chlorine gains this electron, it will become negatively charged. So when atoms lose electron, they become positively charged. And when atoms gain electron, they become negatively charged. So when this happens, sodium will have electronic configuration 2, 8. So this means it has the maximum number of electrons that it needs in the first shell, and it also has completed the second shell. The same thing is applicable for chlorine. It has electronic configuration 2, 8, and 8. So 2 in the first shell, which it needs, 8 in the second shell, which is what it needs, and 8 in the third shell. So in this way, sodium is stable and chlorine is stable. So when sodium gives its outermost electron to chlorine, an ionic bond is formed between sodium and chlorine to form sodium chloride. Let's look at more examples of ionic bonding. A good example of ionic bonding is found between lithium and fluorine to give lithium fluoride. Lithium, with atomic number of 3, has 2 atomic orbitals, and its electronic configuration is 2 for the first orbital and 1 for the second orbital. Fluorine, with atomic number 9, also has 2 atomic orbitals. First atomic orbital has 2 electrons. Second atomic orbital has 7 electrons. Lithium requires 7 more electrons for the second shell that has 1 electron to be stable, while fluorine requires only 1 electron for the second shell to become stable. So, in the case of lithium, it is easier for lithium to lose this 1 electron than gain 7 electrons, so it will prefer the easier one, which is to lose this 1 electron. And in the case of fluorine, it is easier for fluorine to gain 1 electron than lose 7 electrons, so it will prefer the easier one, which is gain 1 electron. So what happens then is that lithium will then lose 1 electron because that's what will be easier for lithium to become stable. So this 1 electron will then be gained by fluorine. So when fluorine gains 1 electron, it becomes negatively charged. Remember, any atom that gains electron will become negatively charged, and any atom that loses electron will become positively charged. So then lithium will have 2 electrons in the first shell because it has lost this one to fluorine, and fluorine will then have 2 electrons in the first orbital and 8 electrons in the second orbital. So in this way, both lithium and fluorine are then happy because they have the maximum number of electrons they require for their shells. So this is what then leads to formation of lithium fluoride. So an ionic bond is then formed between lithium and fluorine to give lithium fluoride. Other examples of ionic bonds include lithium chloride. In lithium chloride, there is an ionic bond between lithium and chlorine. Lithium loses 1 electron, and that 1 electron is gained by chlorine. In lithium bromide, lithium loses 1 electron, and that 1 electron is gained by bromine. In sodium fluoride, sodium loses 1 electron, and fluorine gains that 1 electron. So there is an ionic bond between sodium and fluorine. In sodium bromide, sodium loses 1 electron, and that 1 electron is gained by bromine. So similar thing occurs in sodium iodide as well. So electrovalent or ionic bonding involves the transfer of valence electrons between atoms in a molecule. So this is where I'm going to end for today's lecture. Please like this video and subscribe, and I will see you in the next lecture.